Okay.
Yeah. I have. Is anybody open the quiz yet?
Actually, one thing I wanted to do first, it just part of that assignment for lesson 6, it did say to get the means, see what 3 other people got as their means in that question number 7. So I just thought if we could do that real quick, and that way we can each complete that assignment.
Okay, question number 7 on the prep question.
For lesson 6, it's letter D. It says compare your mean in 7A to the means obtained by at least 3 other individuals. So I just thought if we wanted to go around and say what our means were, then we've at least got that information.
Okay. I did it at work, so I left it. I feel so stupid. I didn't read that part. Sorry.
Did you get one, Juan?
Yeah, but it turns out my computer doesn't want to work today, so.
Oh, so you're not able to access it? I'm sorry.
It's just, it's like taking forever. It does open it.
Maybe it's the internet.
No.
No?
It's not.
Oh, okay.
Because like, it streams. It's just like, it has the hardest time opening Word documents.
Word documents always take time to open. It's like Word documents. Microsoft is not very nice. All right, just let me go through it, and then I think I saved some part of it. I'm sorry, I wasn't prepared for that. I should have just read it. Let me see.
Did you get 4752?
I mean, I think all of ours will be different.
Okay. You got, Christina?
I got 43,700.
Okay.
Oh,
the mean of 5 numbers, the 5 random numbers.
Oh yeah, to do that exercise with the random thing.
Right.
Okay. Well, I wonder why we had to compare them if it was all different.
Yeah, it was asking if they're unusual or not.
Oh, they're on the same ballpark.
Yeah, I got that. I remember that I got around 46,000, but it wasn't at work, so I left the spreadsheet at work because I was doing that at work.
Okay.
I'm sorry.
No, you're fine.
Yeah. Okay.
Megan, did you come up with a mean for that question?
No.
Okay. Okay, then if we're done with that, we can go ahead and go on to the quiz.
Okay, just like last week, I'll have to apologize ahead of time if I have to leave really quick. I just have to take care of my baby.
All right, no problem.
Yeah, no problem.
Oh, okay.
Okay, so I'm opening up my quiz for lesson 6, right?
Yeah.
Hey, it's working fast now.
Good.
Ugh, what a joke. Okay, so if you guys want to run your normal probability applet.
Yes, I have it right here.
Okay. So question number 3 says, when you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed?
Right skewed.
Yeah, it's going to stay right skewed because
Mm-hmm.
5 is not a large sample.
Right, you need to have larger than 30. So even if it's right skewed, as long as you take sample larger than 30 from that, it'll go normal.
Yeah, we'll still be doing
Yeah,
the
that's
thing.
normal.
Okay, so 4 says when you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed? So now it'll just go normal.
Normal, yeah. The larger the sample, the normal that become.
Yeah, so no matter what skew it is, if it's left or right, as long as you take enough samples from that population, you'll get a normal. What is it called? The law of large numbers or central limit?
No, yeah, the central one. Did I write that down? Okay.
He wants to learn statistics.
Yeah. Just can't wait.
Yeah, he's gonna be an accountant. He wants to learn that.
Oh, goodness. You're a stinker. You gotta let me do this. Okay.
I'll go ahead and do question 5.
Okay.
Since you have your hands full. When you're taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? In that case,
Normal.
That's a trick question.
Yeah.
Yeah, you could take
All
one.
of the other ones looks like there are. And do you want me to read the 6?
sure.
When you're taking a sample size of n equal 100, what is the shape of the distribution of mean histogram when the parent's population is normally distributed?
And that would be normal again.
Yeah. Because, as we say, it will always go to normal when it's bigger, larger. So when would the distribution means be normally distributed? Choose all of the responses. Okay, so it had 4 options, and then you have to select the ones that are correct. Data are drawn from the population if that is normally distributed, and the sample size is small. I will check that one. Data are drawn from the population that normally distribute, and the sample size is large. That's also a right one. Data are drawn from the population that is SWEC, and the sample size is small. That's wrong because we don't know. And data are drawn from the population that is right SWEC, and the sample size is large. That is right. So I will say the first, the second, and the fourth. That will be my guess.
Yep, I agree.
All right. And let's let Megan join in.
Number 8.
Yeah.
Which of
Can
the
you hear
following?
us? Oh. Question 8 from the quiz.
Yeah. Which of the following gives the best explanation of the central limit theorem? Do I have to read each one?
No, you're okay. So,
Let's see.
the first one, even though it does give you a normal distribution, I don't think it's the...
Yeah, it's not related to the central limit theorem because it's talking about a population that's normally distributed.
The second one, it just kind of talks about a normal bell-shaped data. But the third one, though, I think it says if the sample size is large, the sample mean will be close to the population mean. And I think that's the closest definition of central limit theorem. I mean, it doesn't have the 30 or whatever.
The one that say if the sample size is large, the shape of the distribution sample means will be approximately normal. I think that's the most correct one, because what's been having like from the top to the 7 is like the telling every single time the same thing. That's
Yeah.
what the other one, yeah, is
Not the
kind of close,
distribution.
but yeah.
I think the fourth one makes the most sense to me.
Yeah, it's related back to the distribution.
Okay, we've almost. I know you guys are all like, oh, we're almost done. Okay, so for the next 4 questions, yay. Let x be a random variable with population mean mu equals 10 and a population standard deviation of theta equals 6. Suppose the sample size n equals 36 is drawn from the population.
Okay, so that makes the formula that we need to do the formula. I got 10.
Right.
And the
So-
formula comes from that reading that
Right.
said, I think it's not theta, it's called a sigma. It's a little lowercase s in Greek. But it's sigma over the square root of sorry, I need to open it back up. Right, that's the formula.
The standard deviation over the
Yeah.
square root of the sample size
Okay.
gives you the standard deviation of the sample mean. But so let's look question 9. What is the mean of the distribution of sample means? And that would be the same mean. It would be 10. Sample means and the population mean are the same. So question 10 is where we need to find the standard deviation of the distribution of sample means,
Okay.
which is
There we go.
1.
Yeah. So
That's
6
what-
divided by 6.
That would be 1. But I got 1.
Got it.
yeah, 1.
Yeah. Is that right? Oh, okay. I was like, that's wrong.
It's too easy. Hold on.
Yeah, I was saying,
Go
no.
back and look. Okay, it says here. Okay, yeah. Okay. So yeah, it's just gonna be the standard deviation over the square root of n. N is 36, so the square root of 36 is 6. And standard deviation is 6 already, so it's just 1. Oh, you guys are lucky you don't have, like, computers don't have this thing where you can smell, because this little guy just has a stinky.
I've been there. My computer
Yeah.
wasn't working, so I had to fix it. I opened it up and then fixed the stuff that weren't connected. So now it's working, but it wasn't working before. It was super small, super slow. So I got memory for the computer. So I know what you mean.
Okay, question 11. Regardless of the distribution of the population, if the sample size is large, n is greater than 30, what would be the shape or distribution of the sample mean? And that's just like
Normal.
earlier. It would be normal.
Yeah.
What theorem would justify?
Yeah. What the theorem will justify the response to the last question? Central limit theorem. That's what I think, right?
Yes.
Yes. All right.
Central limit theorem is related to distribution, and law of large numbers is related to the mean.
Okay.
Perfect. All right, Megan, did we lose you anywhere? Do you have any questions on any of the questions? Okay, so let's submit, see what happens.
100%. Yay.
Nice. Good, good.
All right. Couldn't have picked a better bunch. Oh, now he's asleep. Now that I'm done with that quiz. Okay, let's go on to group or the number 7.
So,
I thought lesson 7 was a bit of a review
yeah.
of everything.
Do you,
You are.
Juan, do you want to restart the video?
Oh, yeah, we have to. Okay, well, I'll send you guys the link and then one of you guys can post it.
Okay.